In this tutorial on industrial instrumentation, we will talk about pressure measurement part 6 and we will talk about the electrical pressure transducers. The topics that we'll cover in this tutorial are strain gauge pressure transducer, potentiometric pressure transducer and capacitive pressure transducer. The electrical pressure transmitters use a pressure sensing element which can be a capacitive, resistive or an inductive element. The passive impedance elements when exposed to pressure suffer changes in the electrical property, that is change in capacitance, resistance or inductive values. These changes are transduced into electrical signal and we obtain electrical signal output in forms of either voltage or current. The electrical pressure transmitters are mainly of three types: the resistive one, that is strain gauge pressure transducer or potentiometer transducer, capacitive pressure transducer, and inductive or reluctance type transducer, namely LVDT, servo, or piezoelectric transducers. The electrical pressure transmitters have three compositional elements and they are primary sensing elements, namely bellow, diaphragm, or Bourdon tube; primary pressure conversion element, namely resistance, capacitance, inductance, or reluctance; and secondary conversion or processing elements like amplifiers and attenuators. The strain gauge pressure transmitter is the passive resistance transducer where the resistance changes under the effects of compression or stretching. The strain gauge elements are connected to the primary pressure sensing elements, namely bellows or diaphragms, and the strain gauge wires form the part of an electrical balance bridge circuit, namely Western bridge. The strain gauge can be used to measure pressure over a wide range spanning from vacuum pressure to 20,000 psi or 140 megapascal. When there is no pressure applied on the strain gauge, the bridge circuit is in a balanced null condition with no current flowing through the galvanometer. But as soon as pressure is applied on the sensing element, the strain gauge comes under either compression or expansion. The strain causes the element to change its resistance value, causing imbalance in the bridge circuit. This imbalance is monitored and the pressure is calculated in terms of electrical output. The advantages of the strain gauge pressure transmitter are that it is small in size and easy to install with no moving parts, reducing device wear and tear. It offers good accuracy, precision, and stability in measurement. It can cater to a wide pressure range spanning from vacuum to 20,000 psi or 140 megapascal. It is not affected by shock or vibration. The speed of response is very fast. It produces high output signal. It has very high over range capacity. The limitations of the strain gauge transmitter are that it is an expensive device, it requires a compulsory electrical circuitry with a constant voltage supply, it requires temperature compensation for accurate measurement. In the potentiometric pressure transducer, the pressure sensing elements that are used are elastic elements which are either bellows or diaphragms. The resistance change is observed in the potentiometer. The potentiometer consists of a movable contact known as wiper that moves over the cylindrical resistance, making contact at one point only. This wiper position tells us about the resistance value. The unknown pressure causes the bellow or diaphragm to deform, causing the wiper to slide over the cylinder. Thus, by knowing the potentiometer resistance, we can determine the unknown applied pressure. These devices are used for coarse pressure determination at low sensitivity. The measurement range is from 0.035 megapascal to 70 megapascal with sensitivity of 0.07 to 0.35 megapascal. The advantages of the potentiometric pressure transducer are that the device construction is simple with easy installation at low cost. The resistance can be easily converted to standard voltage or current output. The limitations of this transducer are that it has limited and restricted resolution. The device is prone to damage due to wear and tear. The make and break circuit causes significant noise in this circuit. The capacitive pressure transducer is another type of electrical pressure transducer, but the capacitive property of the dielectric surfaces is used to measure and attribute to pressure. The device consists of parallel metallic plate capacitors coupled with the diaphragm and is exposed to process with the unknown pressure and known pressure at two of its sides respectively. The measurement range is from 2.5 Pascal to 70 megapascal with a sensitivity of 0.07 Pascal. The electrodes are attached to the diaphragm and are charged by a high frequency oscillator. The electrodes sense any movement in the diaphragm which causes changes in the capacitive value of the plates. This capacitance change is detected and determined by associated circuit components, and either voltage or current output is obtained, denoting the unknown pressure. The parallel plate capacitance is given by the equation C equal to epsilon 0 epsilon R A by small d, where C is the capacitance, A is the area of each plate, d distance between the plates, epsilon 0 dielectric constant having a value of 8.854 10 is to minus 12 farad per meter square, and epsilon R is the dielectric constant, which is 1 for a year of free space. The plate capacitance varies inversely with the distance between plates, so as the pressure increases, the distance of the diaphragm d decreases and the capacitance increases. The capacitive bridge is imbalanced due to this capacitance change, which is recorded in terms of current or voltage. The advantages of the capacitive pressure transducer are that it gives rapid response to pressure changes, it can withstand severe shock and vibration, it is extremely sensitive and can detect very small pressure changes, it has a very good frequency response. The limitations of the capacitive pressure transducer are that it consists of metallic parts and they need mutual isolation from each other. Dirt and contamination severely affects the output results. Temperature compensation is required, otherwise temperature fluctuations cause severe inaccuracies. For more detailed reading, the readers can refer to the following links and references. Thank you.